A question says, find the basis for the subspace. Find the basis for the subspace of the space spanned by these three vectors. Well, okay, what are we going to do? We're going to do our best to find the basis. Remember that you're going to list all of these vectors. -1, 2, and 5 is your first vector in this set. The second vector is 3, 0, 3, and then you're going to list the third vector as the third row, 5, 1, and 8. Then you're going to apply elementary row operations to simplify this and write it in row echelon form. This becomes 1, -2, -5, because the pivot is not 1. So you can multiply the first row by -1. Then you can multiply the first row by, after here, multiply by -3 and add it to the second row. Or at this point, you can say that, okay, I want to multiply it by 3 and add it to the second row. That's fine. And finally, you can take this and multiply by 5 and add it to the last row. It becomes 0, 0, 0 after doing the process, everybody. It's not just multiplying. If you end up with an element that is not 1, you need to convert that into 1 as well and continue the process. So what's the meaning of that? It means that we ended up with 2 non-zero rows. These 2 non-zero rows, W1 and W2, form a basis for the row space of matrix A. That is, these 2 vectors basically span the subspace. So any vector here can be written as a linear combination of these 2 vectors, and these 2 vectors are linearly independent from each other. So here you can use this method to find the basis for the subspace for the space as well.